Last episode, we built one attention head and ran it, but one head only learns one kind of relationship. Real models run dozens at once, and that raises a memory problem that quietly governs how big and how busy a model you can serve. This episode is multi-head attention, and the elegant fix called GQA. Multi-head is exactly what it sounds like. Instead of one attention, slice the vector into say 32 pieces and run 32 attentions in parallel, each with its own query, key and value projections. Each head can specialize: one tracks grammar, one tracks long-range references, one tracks position. Then you concatenate all their outputs and mix them with one more projection, many eyes on the same sentence. Now the catch, and it only shows up when you generate. Writing one token at a time, you don't want to recompute the keys and values for the whole history every step, so you cache them. That's the KV cache. It's a real speed win, but it grows with every token and every item in your batch, and at long context it becomes the single biggest user of GPU memory. The cache, not the weights, is often what caps how many users you can serve. Here's the spectrum that fixes it. With full multi-head, every query head has its own key value head, best quality, biggest cache. At the other extreme, multi-query, all the query heads share one single key value head, tiny cache, blazing fast, a small quality dip. In between sits grouped query, split the query heads into a few groups. Each group shares one key value head. Near the quality of full multi-head, near the speed and memory of multi-query, that's the sweet spot, and it's why GQA is everywhere. The numbers are concrete. Llama 3D8B has 32 query heads, but only 8 key value heads. That's a 4 times smaller cache. Llama 370B has 64 query heads and still just 8 key value heads, 8 times smaller. In the config file, it's one field, num key value heads, and the implementation is almost free. The 8 cached key value heads are just broadcast out to line up with the 32 query heads, no extra parameters. Let's draw the spectrum. 3 panels left to right, full multi-head, then multi-query, then grouped query. Watch the cache bar shrink as we go. Panel 1, multi-head, 32 query heads and 32 matching key value heads. Draw the cache bar at full height, best quality, but this bar is what eats your VRAM. Panel 2, multi-query, still 32 query heads, but now they all point at one shared key value head. The cache bar collapses to a sliver, 32 times smaller, fast and lean with a small quality cost. Panel 3, grouped query, the compromise, 32 query heads in 8 groups, each group of 4 shares one key value head. The cache bar is 1/4 the multi-head height, 4 times smaller, and quality stays nearly intact. Stamp the real models Llama 3.8b 4x, Llama 370b 8x. Now watch the other axis, the cache growing as you generate. Each new token adds a column of keys and values. The VRAM bar climbs with every token. Switch from multi-head to grouped query, and that climb gets 4 times gentler. One last tease, there is a step beyond GQA. Compress the keys and values into a small shared latent. DeepSeek calls it MLA and we'll meet it next stage. Next episode though, we zoom out. The same attention machine can be wired 3 different ways: decoder only, encoder only, encoder decoder. And which one you pick decides what the model is good at. Blast note, B4 carries the teaser to NV12. Thanks for watching. Like and subscribe for more videos like this, and I'll see you in the next one.